Hey guys, this segment is titled Single Displacement Reactions. It's going to be the first of the 5 that we're going to look at. First thing I want to do is I want to make sure you have the right paper in front of you. If you do not have the following paper, you need to yell at me and Mr. Ash to get you it, because you cannot do any of these problems without the activity series. And when I say activity series, it is this sheet right here. Okay? There's going to be a top and a bottom. You will see how it says activity series of metals and activity series of halogens. Both of those are made for your single displacement reactions. The bottom ones, those are for your double displacement reactions. Okay, so as we move forward, I'm going to reference that a lot. I might not zoom in every single time. That is the sheet that I'm talking about. Make sure that you're looking at throughout this video. If you're just looking at the video, taking a few notes, great. Hopefully you get it. But if you are actively engaged and participating, you will fully understand it by the end of the video. So let's look at single displacement reactions. If we think about what this really means, let's write a few letters on the board. Option number 1, you have AB plus C. These are different elements. So A being some element, whether it be sodium, potassium, chlorine, something like that, plus C, okay, so that's another element, yields AC plus B. AC plus B, okay? So that's one option. Your other option is slightly different. Just the A is going to move instead of the B. So let's write what that would look like. And the only difference of what you have going on is now you have A getting kicked out by C. So single displacement reactions is where only one element is being kicked out. In this first scenario, you notice B is replaced with C, leaving B by itself. Second scenario, you see that A is going to get kicked out by C, by another element, leaving it with A by itself. Okay? Couple things that you need to know as we move forward. First thing is your diatomic elements. On your polyatomic ion sheet, I know this is going back just a little bit. If you'll recall, you should know your polyatomic ions. You have to memorize 13 of them. Those are your nitrates, hydroxide, cyanide, things like that. Those will come up, so make sure that you know those. Okay. Also make sure that you're familiar with naming, balancing, so on and so forth, because we will utilize that. Okay. But on that sheet, there are 7 diatomic elements. So I'm going to write down those 7 diatomic elements that you need to know. And then I will explain what diatomic means. So these are your diatomic elements. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So, di means 2, atomic, atom, okay? So diatomic elements means that whenever any of these are by themselves, so suppose there's only hydrogen, we have hydrogen gas. What does that look like? Well, instead of finding one hydrogen atom by itself, you're going to have 2 hydrogens by itself, because it's going to be stable. So diatomic means that when you see these by themselves, there's always going to be 2 of them. Okay? So if I'm breathing in oxygen gas, what does that look like? That looks like O2. That is oxygen gas because it's diatomic. You're never going to see just oxygen by itself. There's always going to be 2 of them. Same with hydrogen gas, nitrogen gas, fluorine gas, chlorine gas, bromine, liquid, okay, and iodine. So when we talk about these, solid, liquid, the rest are gases. So those are your diatomic elements. You need to know that. The rest of them occur not diatomically but by themselves. So if I did not mention it as diatomic, that means that there's only one of them. So if we look at sodium, there's only going to be one sodium when it's by itself. When it's combined as a compound, there might be more than one, as we'll see when we crisscross and do that. So let's get into a couple examples of single displacement reactions and go from there. Excuse me. The first example we have is lithium plus water. Okay? You would have seen it written AB plus C. Sorry, I wrote it C plus AB. It's the same thing, I assure you. Okay? So AB plus C. Now, do you think that lithium is going to kick out the hydrogen or kick out the oxygen? So let me write that out. That's what we have right now. And if we think about it, hydrogen has a positive charge. Oxygen has a negative charge. You're never going to have two positive charges interacting between each other. You're always going to have one positive and one negative. So, what happens? The positive charge, lithium, is going to try to kick out the hydrogen. Lithium is going to try to kick out the hydrogen. And let's see if it works. To see it, you need to look at your activity series. I'm going to hold it up and read it to you. So, we are in the middle of the screen where it says activity series of metals. Okay? You need to find lithium. It's on the very top. Read the very top where it's sideways. Read what that says. Oh, my computer's going to change. So, it says that activity series will react with hydrogen in acids and in water. My screen hasn't switched back, but I'm sure that's what it says. So that means that lithium is going to react with this water. So if I just put lithium in some water, it's going to react. Indeed, it's actually an explosion. And what you get, lithium is going to replace the hydrogen. Let's see what that looks like. I crisscross. Lithium plus 1. Oxygen 2 minus. And I get lithium oxide plus hydrogen. Okay? Do you need to know the states of matter for this? You don't necessarily. Okay? You do know that hydrogen is always going to be a gas when it's by itself. Feel free to put that if you want. Okay? Always make sure that you crisscross, because that's how you figure out, is it going to be 2 lithiums, 1 lithium, 3 lithiums for how many oxygens? You need to make sure that you do that. Okay? But that's your product. Let's go back over here and see. Hydrogen was A. Oxygen was B. And lithium was C. So from the beginning of this video, this should look exactly the same as when we did our letters. Okay? So let's look at a couple more examples. I will keep this video relatively short. I know I'm running already at 9 minutes, but I also want to make sure that you get all the material for this. If you stick copper in water, okay, this is regular copper. If we stick that in water, what's going to happen? And you need to look at your activity series, find copper, and if you look at where copper is, it's going, mine's closed unfortunately, it's going to say that it will not react, so make sure, it will not react with the hydrogen in water or acids. It won't react with either one. So copper plus water gives you no reaction. Copper plus acid, that's hydrochloric acid, also gives you no reaction. Okay? So both of these give you no reaction because the activity series says copper plus water or acid. Nothing's going to happen. Let's look at one more before we move on to another way to do single displacement reactions. Zinc plus hydrochloric acid. You will see this demonstration during class, but zinc plus hydrochloric acid, let's see what happens. If we look at our activity series, it says zinc will react with the hydrogen and acids only. That means it won't react with water, but it will react with the hydrogen and acids. This is hydrochloric acid, HCl. If hydrogen's first, it's an acid with the exception of just water. So let's crisscross this, see the products that we get. Zinc, 2 plus charge, chlorine, 1 minus charge. You crisscross. ZnCl2, if you're struggling crisscrossing, make sure to look at the video. You need to know how to crisscross. You have to be able to crisscross to do these. Zinc chloride plus hydrogen is by itself. And when it's by itself, it always gets a 2. It's diatomic. Okay? So, hopefully you can see that. I'm going to move my light just a little bit. Hopefully that's the one that's blocking it. Just a little bit. Zinc plus hydrochloric acid gives you zinc chloride and hydrogen gas. Okay? I'm going to show you another way to look at this activity series. If you look at it, some elements are above others. If the element is higher, it is going to want to be in the reaction. It's going to want to be in the compound. Okay? If it's lower, it's going to be kicked out a lot easier. Okay? So whatever's higher wants to be in the reaction, whatever's lower wants to be kicked out. So let's look at a couple examples and see if they make sense. First example, let's just do salt plus lithium, see what happens. NaCl plus lithium, okay, Ab plus C. Look at your chart. Lithium is a positive charge, so is sodium. So you're going to find out which one's higher, lithium or sodium. Well, lithium's higher. Lithium will kick out the sodium, okay? Lithium will kick out the sodium. Leaving sodium by itself, it's all lonely by itself. And then you crisscross what's left. Well, you have lithium and chlorine. Lithium is the positive charge, so it goes first. Lithium, chlorine, 1-to-1 ratio, lithium chloride. LiCl. Okay? So you have NaCl plus lithium gives you sodium plus LiCl. Okay, so that's an example of single displacement reactions. The higher one will take the place of the lower ones. Let's look at another example. Let's add zinc to it. If you look at your activity series, salt plus zinc, well, which one's higher?